And we're live with the fifth and final panel discussion. We're going to be discussing designing modern AI systems with a bunch of heavyweights across different industries. To begin with the discussion, we're going to go around the room in alphabetical order and allow the panelists to give a minute introduction into who they are and some of the things that they've done. To kick us off, Brian, would you like to begin?
Thanks. Great. Hi, everybody. I'm Brian Garr, and I've been in this industry since the mid 90s, in the AI industry, that is. I spent a decade with IBM running their voice recognition business. Had my own company called Linguisys, which was in the AI business, as well as worked with multiple startups. And now I'm the chief product officer for Pure Talk AI.
Chris, would you like to go?
Sure. Thank you, Joaquin. I'm Chris Andrassi, co-founder and CEO here at Astral Insights, and we are a full-service AI solutions company as well as consulting agency focused on enterprise supply chain applications. So building intelligent solutions to be more intelligent, more responsive, and ultimately build more efficient supply chains.
Thank you, Chris. Jans?
Yeah, my name is Jans Aasman. I'm the CEO of France Inc. Our main product is Allegograph, and a graph database and knowledge graph product. And yesterday I gave a talk here about neurosymbolic computing, where we combine generative AI, traditional logic, and machine learning in useful applications. And my main domains are in healthcare and in call center analytics.
And Kurt?
My name is Kurt Cagle. I'm the editor of the Cagle Report. I've been covering the AI industry on and off since about the mid 2010s, and have been an industry analyst, senior architect, and consultant with a number of federal agencies and Fortune 50 companies. I have my own company, which I use primarily for consulting purposes, and have been a big champion of knowledge graphs and the integration of symbolic knowledge graph-based systems with LLMs.
Thank you. So with that, we have a bit of a background on all the panelists. Let's lay a little background on the context of the conversation. I'm going to throw out a few simple questions, and then we're going to dive into the deep end of the pool. What is a domain? I know it's a very generic question.
Yeah, so it's interesting the way that I think about domains being a particular vertical. You could say my domain is conversational AI, but at the same time, you could say our domain is healthcare. So domain can have multiple meanings in context. On the other hand, ChatGPT has no domain. It's everything to everybody. So domain is an interesting word.
Yep. Jans, I think you were mentioning industries and scientific, academic, or other applications.
Well, Brian kind of said it all already, right? But the domain is, if you ask ChatGPT, give me 10 interpretations of the word domain, you'll get a lot of them, right? So,
all right.
It's better to move on to more specific questions.
I think in the context of our conversation today, domain is a vertical industry. The domain might be healthcare, the domain might be financial services. I have a feeling as we use the term domain today, it's primarily going to be used in that context.
Yeah,
perfect.
I would actually clarify that a little bit. I also think that a domain is essentially, call it a business context. There's a lot of context that we're going to be dealing with in these various arguments, and realistically, the domain is essentially a topical organization of that rather than necessarily just, here is a business vertical. It's generally, if I could assign a particular set of topics that describe the information space that we're working with, that domain is that information space.
Yeah, I think that's a good point. And we often think of it in a sense of business function as well. So in the context of supply chain procurement, looking at that process, the associated workflows and decisions may be very different than, say, inventory management or order fulfillment.
Okay. Well, with that idea of scope of ideas or knowledge, what is a model?
Well, that's even worse than domain.
Yeah.
Yeah.
Models are tough. I've been I've been working with different definitions of models for a long time, and they really mean here is a way of representing a process or flow or domain or other things. So they're essentially, here is a bit of reality, or here is a representation that effectively is either going to be used for predictive analytics or forensic analytics. With regard to how it builds out. So when we talk about an LLM, in general, what we're talking about for that model is essentially, here is the constraint of information that we're dealing with that is simulating the overall space.
Okay.
I mean, when I saw that question, and the first things that popped in my mind were, are we talking about an LLM model? Are we talking about a scientific? Are we talking about an OWL model? Or I'm doing a project right now about artificial societies, right? This is a 30-year-old book, but it's one of my hobbies to model artificial societies. Like, can I make a model that develops over time, right? That kind of does the same thing that society does, right? And what are the inflection points? What are the parameters, right? I mean, but you can fantasize as much as you want about the word model, right?
So let's move on to something more constructive. Artificial intelligence is a term that has been conflated to mean many different things to many different people, whether you're mass market or you've been in the industry for 20, 30 years. That definition changes in granularity. And I'd like to ask, what is the difference between a symbolic model or of artificial intelligence and a statistical model of artificial intelligence?
Well, we can't get into the discussion of what artificial intelligence itself is.
Oh, for sure.
Sorry, I mean that's a whole panel in and of itself. If I think that when we're talking about AI, I kind of define AI as this is what is going to be considered passé technology 10 years from now. And that seems to be about the best definition I've ever seen. Is it's always it's the really relevant stuff 10 years from now. By the time we get 10 years from then, it's kind of like, no, that's not AI. It's just machine learning. Real AI is this, and we'll continue to work with it. I think that the real challenge when you get into the whole focus of AI is that you have one faction that basically wants to say, hey, look, we are simulating human beings. And we're dealing with this whole process of what is a human being as a part of that. And there's another faction that's saying, no, we're basically creating a model that allows us to take certain components of our interactions, things like speech to text, talking, integrating into an overall package. And that particular vision of artificial intelligence is key in our understanding of intelligence, but it's not either really artificial nor is it intelligence in any real sense. It's still largely stochastical processing, and we keep finding that there's a limit there. And I've talked too long, so I'll let someone else talk here.
No, that's a great way of putting it. I've always defined AI as a computational model with a measurable error rate. So it's, in other words, if it doesn't have an error rate, then it's not AI. It's just rote. It's just, someone hard coded something. By its nature, AI, at least in its current implementation, has an error rate that's measurable. You can improve on that error rate, but it always is going to be a measurable error rate.
I want to just say, I mean, what Court said, right? I remember when parsing was AI, right? And then it was just good technology, right? And then intelligent search, right? A-star search was mentioned, was kind of very advanced search algorithm, right? And then it just came a typical computer science, right? And all the time, right? Machine learning models, right? It was magic, right? And then it became just, okay, well, it's just math, right? So we've been moving forward, and now we're looking at AGI. By the way, I don't even want to talk about that, but I also remember being a psychology student, right? And we were looking at human introspection and a rule-based system, how humans were thinking, and then we have these damn chess computers, right? They were way better than humans. And what is really AI, right? That the chess computer that beats humans, or a model that tries to mimic human behavior, right? But was way worse at playing chess, right? So that's a very, very old discussion, right? Statistical versus brute force AI, right? It's got nothing to do with human principles, which is even different than statistical AI, right?
Yeah, and from an application perspective, we often look at the distinction between transactional work, more repetitive rules-based work, and knowledge work. Thinking of AI as something that can fundamentally achieve some aspect of more creative knowledge work, whether that's simply providing topical insights, text to speech, or if it's going all the way to truly doing the job of a human, such as a call center agent, or even, say, a logistics analyst to compile pricing and give information to, say, an executive, for example.
But if I may latch on to what Brian was saying, he talked about the error rate, right? Artificial intelligence is what marketing people currently sell as the smartest thing they can do, the smartest thing they can sell, right? It's 100% marketing term. Let's not kid ourselves, right? AI is a marketing term.
Yeah.
Nothing to do with the underlying technologies. There's so many technologies. You got to sell this stuff, right? And you need to get money for funds, so you call it AI. But it's just a dumb word, right? It's just like the word knowledge graph, for example, right? I mean, it's just.
So I'm not sure that's true anymore, because if you look at ever since LLMs came on the market, and you can't trace from the beginning of a prompt to the exit of the result what's happening inside that box. That box is a black box, and you don't know what's going on inside.
That's just because you can't trace all the weights being changed on the fly, right? In training, it doesn't mean that suddenly makes it this magic thing called artificial intelligence. It's just
To kind of go back to Joaquin's comment earlier, about the distinction between stochastic and symbolic AI. What we're basically dealing with when we talk about symbolic AI is largely something that has traceable patterns that you can basically apply. You can apply algorithmically to be able to derive a repeatable outcome, and that repeatable outcome, basically means that if I have a purely symbolic method, when I start something with, here is a set of context, I can expect to get output that is consistent from attempt to attempt. With a stochastic AI system, like an LLM, on the other hand, what you're basically talking about is a mimetic space, and that mimetic space is basically going to look at the vectorization of pretty much very arbitrary documents that essentially define the characteristics of that space, and then everything becomes proximity. I mean, it's in some respects we're not that far away from talking about the way the search engine has worked for really about the last 15 years. The primary difference being that with a search engine, what we're doing is saying, I'm retrieving a document or a link to a document back, whereas with a typical LLM-based approach, what you're talking about then is actually retrieving concepts back. And those concepts may actually change from one iteration to the next, because our context is changing, because the way that we're working with. And so that's really one of the big distinctions there. I'm not really sure it's really stochastic versus symbolic, because you can do stochastic processing within a symbolic environment. That's just a matter of basically saying, hey, I'm doing what amounts to Bayesian analysis, and putting weights into your system. It's just that it's predictable in a symbolic system. It's not necessarily predictable in an LLM.
Yep.
So now in the context of that domain, that model, and kind of talking about the differences and similarities in symbolic and statistical or probabilistic AI, can we define what it means to develop an AI system?
Don't understand the question. What
So
it means to develop an AI system.
we've talked about domain representing a field of knowledge or a scope of something, and we've talked about models being representations of that domain and variables, and sort of being able to break it down. How do you design a system around a domain to fulfill a purpose?
I mean, again, it's context driven. So I'm in the conversational AI world. So the first thing I think about is we're going to have a conversation with somebody, and either through text or voice, and that person's going to ask a question, and we're going to deliver an answer, or we're going to ask a question back. So we're designing systems that are conversational in nature, and therefore the model on a bigger scale than the LLM is design a conversational system that's pleasant for the end user.
Yeah, and a piece of that, going back to the idea of a model representing some fundamental thing, whether it's a process or concept or behavior in reality, we often go to, before actually putting down plans to design any sort of system or even picking the exact tooling, really looking at approximating the thought processes that are actually happening in real life. And so it's one thing to represent a business process in a flow chart and a diagram where I'm going through which vendor I want to actually purchase from, and then going through contract negotiation, and then actually purchasing and making a purchase order. But there's often this black box in the sense of what are the humans actually going through cognitively as they go through that process. So in order to design a very purpose-built, influential system with LLMs, it often starts with really decomposing and understanding how the humans who are actually executing the real process think about that process. And that's one of the key inputs.
Yeah, there's a concept that you see a lot in the information architecture space, and that's the user journey. And the user journey is actually, in many respects, I think, is one of the more important pieces that is kind of moving away from the marketing and selling to the actual design process of building out these, because you are in essence saying, I am creating a set of users, a system of users, and those users are basically interacting with one another. Some of those users may be humans, some of those users may be bots of some sort. And then the question becomes, what is the interaction what is the desired interaction, and how do you keep that interaction from necessarily going off the rails? How do you keep it so that it's basically still relevant, and provides at least some answer to the question that's being asked as part of the prompt? And I see that as actually informing more and more. We're thinking about user journey increasingly as this ties in very closely with the whole notion of a prompt-driven architecture.
Right. It's one of the reasons why we've gone to smaller LLMs instead of trying to use ChatGPT, which is everything to everybody. So we have domain-specific LLMs that keep things inside the rails.
Yeah, I think the comment on user journey is also very interesting because user experiences now are so much more multifaceted, where we're not just talking about designing screens. Now all of a sudden we're talking about, is there an AR component, a VR component? Is there a speech component? So the amount of variability becomes very large. So the degree to which we can really understand that user journey is critical to keeping the system inbound.
In my eyes, a system has inputs, it has a transformation, and it has an output, and it fulfills a purpose in whatever environment it exists. I think we've outlined a lot of key elements here, and I think we've also introduced the concept of human actors and artificial actors. Um, Recently, a lot of people have been writing about and talking about agenic in AI and what it means to create something that produces some sort of result in a system. So, can we discuss what that means to have an AI agent in a system?
So we had this conversation sort of off camera, but to me, an agent is someone who's sitting in a small space in an office full of people with headsets on, taking phone calls. To transfer that to the domain we're talking about, an agent is an intelligent chatbot, for example, or voice bot that is replacing that agent that's in his little space with his headset. So agents can mean many things, just like domains can and models can. But in my domain, that's what an agent is.
Yeah, we often draw the distinction between the term co-pilot, and it's sort of been branded by Microsoft, but you certainly hear it used by others, more of a co-pilot as an assistant throughout a workflow. Think of it as almost a virtual assistant or a virtual knowledge worker of some capacity. Maybe it's doing analysis for me, compiling it, and then giving it to me to make the final action or decision. Whereas we think of more of an agent as something that can actually accomplish an end-to-end workflow for a human. Without a human in the loop. And to Brian's point, there's certainly many different ways to define it. But in terms of a business lens, we've typically drawn that distinction between human in the loop and augmentation of a workflow versus true automation, true autonomy throughout a workflow.
Yeah, for me, agents have been, for the last 40 years, been an independent piece of software, right? That has a contractual input and an output and some complex processing inside. And AI agents just means that the processing inside became even more intelligent, right? And then in good AI systems, you also have like a meta agent that looks like a god at the interaction between the agents, right? And tries to check whether agents die or whether they have faulty responses or whether they're slow or say dumb things, right? But I also want to include the human as an agent, right? Because you could have a system, right, and just ask a user, is this good, is it bad, right? So we have a system where a big healthcare knowledge graph where we use an LLM to generate Sparkle queries, so you can just say what you want, right, and it will write the Sparkle queries for you. But basically, you always need a human in the loop to say, is this, for example, is this? So you do the query, you get a Sparkle, you do a natural language question, you get an answer, right, in terms of a Sparkle query, and then the human being looks at it and at the results of that query, and then if it's okay, then we add it to the successful queries, right? And at some point, we train the system on the successful queries so to make the system better. But the human being is literally just like a little black box in the system, right? With input, the Sparkle query, and the shackle with the knowledge graph. And the output is yes or no. And if it's yes, then it goes into the vector store, right? It stores all the natural language queries and the sparkles that were correct. And so slowly over time you train. But the point being, the human being is an independent box in the system that's not better or worse than any of the other systems, right? So
I think we've outlined some very critical components in this discussion of what it means to design a modern AI system.
Yeah.
A system representing an organization that has actors. And Chris mentioned, you can have autonomous agents, or you can have augmentations, which are tools, which can be equipped by human or artificial agents. Um, so now we're discussing something that's a little bit non-trivial, and something that requires permanence, and that spans time, and you have to subject that system within an environment. So with these new ideas or concepts, uh, what would you say are critical components of an AI system?
If I can jump in on that one. One of the key things that you run into, and I mean this is true of really any distributed system, is that you are the distinction between the conversational model, the prompt response, and a more agentic environment is largely the fact that once you get into an agentic environment, once you're basically saying, I have an orchestration that needs to be done, then for starters, one of the things that happens is that you get into a mode of orchestration. You get into a mode where you're basically dealing with asynchronous processes, and those asynchronous processes may be relatively small. They may be relatively large. If I have something where I say I have to get someone to buy off on this, and that someone basically then says, okay, there's an email as part of this process, and I can't respond until I do that email, you have to have a system that can basically say, okay, how can I make sure that in this process of putting together a complex workflow, that I can facilitate this one action that's off talking to human beings to be able to accomplish a particular task. And I don't think I think we're beginning to get to the point where, dealing with the complexity of asynchronous networks is actually becoming a fairly critical part of developing agentic systems. Because you can't just go in and say arbitrarily, okay, I send something out, send something out, everything comes back. Things are going to come in orders that you can't predict. Some things are not going to work at all and have to have fallbacks. And so, you get into a much bigger level of complexity that really has only minimal actual interaction with AI. AI becomes a part of that. It becomes an operator. It can become an orchestrator. But the real role here is basically you're moving into something that is a larger scale, systemic, asynchronous environment.
Mm-hmm.
Yeah,
I may be wrong there, but
no. When I just talked about my definition of agents, but that was an important thing that I missed. Right, it's asynchronous. Right, it's not orchestrated by one computer program. Right, it's running independently of each other. It can be completely out of order, and it has all kinds of problems with itself. Right, that's the hard part about agent systems: overloading agents and doing things out of order, and then dealing with that. And before you know it, you have huge programs inside an agent just to deal with the ordering issues, right? So,
and the same thing is happening with the actual conversations that you have. So, unlike transactional systems, which may have been called AI but probably weren't, the LLM-based systems are open-ended, so you don't have. It's not transactional. It's not prompt answer, prompt answer, prompt answer. We have a system for loneliness for seniors that are lonely. That's just purely conversational. And as a matter of fact, I spent a lot of time talking to these systems, which is why I am the way I am. But I told it I was depressed because I hadn't played pickleball in a month, and so it went down a whole thing about how do you feel? Sometimes if you exercise, it can make you feel better. How long has it been since you saw somebody, or did you meet your doctor? So these open-ended systems are truly unique in my history of being in the AI world, and I would call them asynchronous because they're not transactional. They're not a series of questions leading to a summation.
Mm-hmm.
I think that Kurt also brought up a very important concept. Whether you have a human operator or orchestrator, or you have a machine orchestrator, I think Brian, in the example that you're talking about, having someone call someone that's lonely and talk to them, that would be the artificial orchestrator. But in the situation where Chris is describing an analyst that performs a job inside of a predetermined structure, that would be an artificial agent, right? How would you define that?
Was that for Kurt?
I guess I can take that. Yeah, the thing we have to be a little careful about is these terms get very fuzzy after a while. When you talk about an agent in that regard, I've written to Brian's commentary. I've actually written systems where I essentially have multiple personalities within an LLM talking to one another. And, that is an exercise where you're basically saying, okay, you want to be able to create a simulation at this point that is consistent and meaningful. And it's actually, again, something that's a trainable piece, but it's also a piece that you get back into the world of conversational AI. And you look at this and saying, okay, if I'm looking at my LLM as essentially an environment to create a model or a simulation of a conversation, whether with or without agents, then what you end up doing there is to really try to recognize that these are they have to basically be separatable. They have to be things that have their own separate existence, even within the scope of the particular operation that you're talking about. And so that's why, when you talk about agents, that gets very fuzzy, because those agents may only exist within the context of a single conversation. And that ultimately you have to go back and then from that say, okay, now can I use this to train? I found when I was doing the LLM work for that, one of the problems that I saw was that after a while, everyone came to agreement. And, I had to specifically go in with these and train them about, hey, no, this person is not going to agree with most of these conditions. How do you handle that particular conversation? How do you deal with something where you can't get nice agreement? And that's a real challenge from what I've seen in terms of trying to build good conversational agents, is that they have to basically be capable of adversarial contact.
Within your respective domains, where do you begin to assess how you employ, whether it's tooling or whether it's autonomous agent, or how do you provide the necessary infrastructure to even begin contemplating artificial intelligence, whether it's probabilistic or whether it's symbolic?
Can I still go back a little bit to the agent thing?
Yeah, for sure.
Because, I've been doing software for the last 40 years, and various labs I worked, right? There was always a group of people very enthusiastic about agents. And I finally had a colleague, an extremely smart colleague, that said, Jans, this is just like the toothpaste, right? If I squeeze here, it gets thick here, but if I squeeze here, it gets thick there. And what he meant is, it's very alluring, right, to have a little piece of software with intelligence in it that do everything you want, right? But then you get in the problem that, like Kurt said, you need two agents to do different things. You need arbitration. You need an orchestrator. Now, or you write a huge orchestrating program to keep this agent simple, or you make these agents very complex, right, to make sure that the orchestrator doesn't get too complicated. And in the end, you have to write the same amount of software, right, to get the thing going. And it doesn't matter. And maybe there are certain situations where an agent approach makes a little bit more sense. Sometimes you just write a monolithic program, right? But look at microservices, right? There's already a long time, microservice was the future, right? Now people are going back, right? It only creates more chaos, right? So, and by the way, I think before we started this, I talked about that one of my hobbies is to create artificial societies, right? Where you look at the population development and everything that can happen to a person in the population, right? They marry, they get children, they die, right? They get jobs, they get laid off, they travel, and I tried both approaches, right? Make every person an agent, right? Or you write a modeling program, and the amount of code, if I look at my two versions, are roughly the same, right?
Mm-hmm.
And it didn't matter. You still have to think about every important decision in your system and whether you want to put the decision power in the agent or in the orchestrator. So in that sense, I thought it's a kind of a weird conversation to talk about agents, unless you think it more in terms of microservices, right? Where you have a weather agent that will just tell you about the weather. Okay, well, great. You have a weather agent, right?
Yeah.
But if it's part of a very complex collaborative decision structure, you're fooling yourself if you think that one approach is really better than the other, right? But there's a lot of services, right, that you can model as an agent. The weather agent that will tell you the weather today and tomorrow, right? Well, of course, you can ask two agents. My wife has an Apple, I have an Android. Our weather thing always says different things, right? But okay, that is an aside. Anyway, go back to your question, Joaquin.
Yeah, where do you begin to define how you develop the necessary infrastructure to employ some sort of intelligence, whether it's probabilistic or symbolic? I know Chris was saying embedding an analyst somewhere in the supply chain to support the flow of information.
Yeah.
How do you scope that out?
Yeah, it's often the nature of the workflow, not thinking of AI as a panacea. And often companies think that that's going to be the answer, is build an LLM chatbot or build a co-pilot. And a lot of the times it goes back to the underlying data infrastructure, and garbage in, garbage out, a tale as old as time, right? But something Jan's mentioned, this knowledge graph, and what we think of as a semantic data fabric, a representation of all of the enterprise's data. It may include external data, weather information, commodity prices, macroeconomic information, et cetera. This unified representation of enterprise data that can be used to ground the LLM models in the actual context of the business. And so this may look like building a specific agent for purchasing, building a specific agent for claims processing. But all of those agents then have the contextual awareness of the processes and the relationships that are occurring in a business. And we do find that a knowledge graph is the structure most conducive to an LLM to be able to actually retrieve and do something with that information.
Yeah, if I can jump in on that. I tend to work on the same basic principle, and that is that there's actually two processes to building an LLM. There's essentially the initial process of training, and then there's the process of essentially retrieval, which is retrieval augmented generation. When you're looking at a system, whatever that system is, and regardless of whether you're actively using the LLM by itself or not, one of the key things there is often to say, look, can I create a representation of my system through some kind of a knowledge graph, and then take that information that I built and use it to essentially ground that knowledge graph originally, use it as part of the training process, that you can essentially say, okay, I'm going to basically pass into the training process, here is Shackle, or here is Owl, or whatever. Here is my taxonomies that I'm working with to basically define references. Here are the key IRIs that I'm working with so that I can basically create associations within the mimetic space to be able to then say, when I'm talking about this, here is a clear identifier to be able to work with that. And once you have that in place, once you basically preload that model as part of the training, it doesn't have to be exclusive, but as part of the training, then you end up with a situation where you can go back in later with a RAG type system and be able to say, okay, you know already about the structure, the schema of the information that we're talking about. And if you already know that, then when I request information about the structure of a particular entity, then I can get it from you. And I can utilize that to help me build things like transformations, as Jans has been talking about, or queries as things go, Sparkle updated and things like that. If you have that, then it makes it much easier to then create synergies between your knowledge graph and your LLM. And then you use the LLM primarily as a vehicle for transformation, natural language processing. In some respects, it can sort of, depending upon the LLM involved, it can act as a vector store. But all of these things are really driven by having a good foundational knowledge graph in the back end. And I agree very much with Chris on that, that the purpose of that knowledge graph is to basically embody the structural relationships that exist within the universe of your particular organization.
Yeah, a very quick thing, a fascinating point on that. I think what you mentioned with graph RAG is that the definition of, say, the term customer or the term account might be different person to person. So the other piece is that the system understands that, hey, when Bob Smith versus Joe Smith are talking to this system, the same word means something very different in each query, and being able to actually understand and accommodate that.
It also ties into a significant extent with the issue of standardization. Because, yes, you're going to have differences with regard to how people conceptualize what a customer is. But realistically, if you're basically talking about communication that identifies this for external systems, you want to have consistency. You want to be able to say, if Bob and Joe both are talking about customers, we have a definition for a customer. We have a way of being able to say, this is the relevant information that we want to talk about with this customer. We can add to that. We can add schematically to that. We can even go with an open world assumption and say, this is information that we don't yet have schema for, but we also have mechanisms to be able to facilitate those particular cases so that as we learn, we can evolve more information about the information we don't know yet. And then use that with the man in the middle type of, with a person in the loop, to then build out the knowledge graph to make it more sophisticated and more knowledgeable about the organization over time.
So that example that Jans illustrated with the toothpaste one, I guess, showcases whether you want to create an AI system that directs and orchestrates the flow of information or actors in an organization, or you want to create a unique autonomous agent fulfilling jobs in that system. But I think Kurt and Chris are saying, irrespective of whichever way you want to go, you need to have some level of integrating the knowledge, the concepts, and the different flows of information across the organization via knowledge graph. What other kinds of critical components would go into an AI system? Jans, you were going into the architecture of neurosymbolic AI, and you're illustrating the usage of machine learning techniques, the usage of LLMs, and the usage of a knowledge graph. So maybe we can explore a little bit of that.
Well, so we have a knowledge graph that we give out to hospitals, right? That uses real patient data, but de-identified. It's called Mimic 4. And so a knowledge graph that has that with clinical trials, and UMLS has a taxonomy, and PubMed, what have you, right? And we represent patients as series of events, both as a graph, but also as a series of events over time. What happened to you? What medication? What test? Whatever. And so we train we do classical machine learning on these events. So you have patients as event, right? So you can train a machine learning model, usually recurrent neural networks, to train whether or not a person is going to get something, right? But because an LLM has read every medical article on the planet ever, right? It also is incredibly good, especially at rare diseases, to do predictions. So I can give the same sequence of event for a patient to an LLM, and it will come up with a prediction. I can write logic programs, right, for common diseases to look at your past, right, the series of events to see, oh, is this person going to get diabetes or GERD, all right, or a stroke? And finally, we actually also give series of events to real life doctors, right, and say, okay, given the history of this patient, what are the most likely things going to happen? So now I have 4 different AI systems that each come up with a slightly different prediction. And now the question is, who's right? I mean, if it's a fairly common disease and I'm in a big hospital with a lot of data, then I probably would trust a machine learning model almost the best, right? But for rare diseases, I would trust an LLM better, right? And doctors always think they're right? And well, anyway, you can take logic from expert systems. So it's an incredibly interesting issue to deal with, right? I got 4 AIs that each have their incredible strong points, right? So who's right? Does that make sense?
I like the way that one of the WebMD does it, where they have a symptom checker, and you click off what your symptoms are, and it basically tells you whether it thinks how strong it feels about its conclusion, whether it's a moderate, whether it's strong, and it never gives you one diagnosis. It gives you N best, and then you can figure out which one. It tells you this is the top one. Here's the next 3 in line. And you can decide for yourself, or you can ask your doctor, but it doesn't try to give you an answer.
No, it's not allowed to even, but yeah.
Right.
In fact, go on.
Yeah, but so that's an example of the medical example, right, where multiple systems can make predictions, right? And sometimes some of them will right. But yesterday I also talked about an example that might speak to Brian, that is where we analyze calls between agents and customers, right, and extract more than 50 different insights out of a conversation. Like, did the agent build up an emotional connection with the customer, right? Very important for sales, right? Well, we can finally with LLMs we can do it. We tried it in the past with taxonomies, and it was endless work. You never got it all. LLMs have a really easy job doing it, right? And so we extract these insights out of the conversations, but then we take we turn the 50 insights that whether or not they happen, and can put that in the machine learning model, right, to check what works in a particular part of the sales cycle, right? So now you're using 2 technologies, right? But now you're using them together, right? The output of one system becomes the input to another system, right? And then you have logic about how to deal with it, right? In going forward,
right?
And right now, when I talk about neurosymbolic AI, we now have about 5 different examples of a completely different way of combining different AIs, right, to make better applications. Does it make sense? There's not one pattern there. It's just what works, that works, right? And,
right.
But it's super exciting right now to have all these tools at hand, right? And it's all becoming so easy to combine them. So now it's just a matter of empirical testing, right? What works and what doesn't work.
Yeah, I think one of the things you're seeing now, and it's good because it's always been one of the big problems that I see in a lot of businesses, is that we're kind of moving away from this notion of saying there is one right answer.
Yeah.
We are moving into the mode of, this is what Bayesians do, but they are, Bayesians tend to be very difficult to basically conceptualize. Bayesian is basically a probabilistic decision tree when you get right down to it. And when you start looking at the fact that there is information that you're talking about, these are guesses. These are essentially predictions that you are making on the model that you are creating here. And they will basically give you not only different answers, but also different paths of remediation for being able to deal with that different sets of scenarios, to be able to say, These are the consequences. These are the actions that you can take if this happens to be true. And that's something that when people are working with these systems, engineers kind of sort of understand this because they get into, especially systems engineers, understand this from the standpoint of, okay, I need to know what is the likelihood of this particular thing breaking, or what is the likelihood of this particular person having COVID. And what is the implications of this basically come from that particular tree. But it's now slowly beginning to permeate not just that engineering mindset, but also the business mindset of saying, look, you don't necessarily know the truth. You can only kind of approximate it, but here are the implications if you take these paths. And it's a very different way of thinking, and I think it's a very welcome one. It just requires more awareness of the individual that, look, you don't have true or false. You have varying shades of gray.
Let me ask Brian how he handles that in the architecture of having an agent be a natural language interface with patients who may or may not stay within the scope of a conversation.
So again, what we've done is we have bespoke LLMs and we have our own proprietary code that's called guardrails that keeps people in the domain that we've chosen. So, for example, a patient, and we do a lot of remote patient monitoring, where we're just trying to call the patient every day and say, "Did you take your pills today? If you didn't, hold on while you go take your pills." So these are all very domain driven, and out of scope isn't really an issue. If they ask something about football, we'll just say we love football, but we really want to check on how you're feeling today. So we'll always bring it back to the domain we're working in.
What about you, Chris? When you design agents that are serving some sort of limited function as a job, augmenter or fulfillment, where do you begin with that?
Yeah, again, it typically starts with mapping out the workflow and understanding where the points are for more pure transactional automation, which may not require an LLM or even machine learning for that matter. It may be more rules-based RPA, like we've been doing for years and years. And then looking at the points at which there's a collaborative, more strategic decision being made. And oftentimes in a supply chain context, that's inherently cross-functional. It's not just a fulfillment team, but they're also talking to logistics. And so it often gets in this murky area where teams need to collaborate across multiple different processes. And so when we get in situations like that, then we start thinking about how can we build some sort of conversational type system that can get in the room, so to speak, with these teams and assist them in actually making some of these decisions. And then the actual choice to say, do we go with more of a pure supervised learning predictive model, or is this a series of, say, individual LLM agents? That really just comes down to the nature of the information needed to make whatever the decision at hand is. Is it a pure decision of what do we expect demand to be for next month? Perhaps that can be more of a supervised learning question. Now, if it's something that's a bit more complicated and involves a bit more human level reasoning, that's where we might pull something a bit more complicated out of the toolkit. So it's really starting with the simplest possible answer and adding increasing complexity only as it's needed and as the quote unquote easier solutions don't cut it.
And you mentioned the usage of knowledge graphs as an integral part of this recipe. Knowledge graphs also allow you to extend and integrate different sources of data. So with the initial mapping out of what transactional tasks can be automated, and as you're saying, you evolve with the implementation of agents of increasing complexity. How do we support the evolution of a system with the use of a knowledge graph?
Yeah, I mean, a knowledge graph ultimately allows for new data sources to be integrated into the existing ontology and taxonomy, as we talked about earlier. And so it's fundamentally much more flexible in the event that the company makes an acquisition and has a new ERP system. or IT mandates they need to upgrade to SAP for HANA from maybe B1 or an on-premise instance. All of those things in the more traditional world of data warehousing were very intensive data engineering workloads, because now we have to integrate into these very rigid relational-based schemas. And with a knowledge graph, once you have that ontology defined, and there are some machine learning tools and providers that we work with that actually help new data be integrated into those existing ontologies, but it allows you to actually do that on the fly and do that in a lot more flexible way. So we oftentimes do recommend moving more in that direction of a data fabric with a knowledge graph, rather than trying to over engineer this data warehouse, data mart approach, which inevitably is very, very intensive on data engineering, not to mention what we already discussed, that it's not necessarily as good at giving LLM models context as a knowledge graph is. So it really has two benefits: being very flexible and scalable to introduce new source data, but also better context for the LLM, ultimately more intelligent responses from the LLM.
So I see two approaches that have been discussed here. Chris is more of a use case driven expansion, and then Jans, you completely ripped out a new system and designed it from scratch, right? Based on existing functionality for the call center?
Oh, the call center. Well, we started out with a system where we had a workflow call center that was sitting on massive amounts of conversations that they didn't do anything with, right? So we used a taxonomy approach to specify things that we then could use for insight extraction, like did the agent talk or the customer talk about whether they had the budget, whether they had the need, the timeline, all that stuff, right? But it was like endless amount of work, right? With the taxonomy, you never can stop writing regular expressions and rules and alt labels and pref labels, and it was really a breath of fresh air when we switched over to LLM, right? Where we now can ask intelligent questions of a conversation and even give examples of what we want to get. And it doesn't matter if now and then the LLM makes a mistake, right? I mean, for Brian, if you have a conversation, it's really important, right, that you can't make too many mistakes. But if you do analytics, right, that if you now and then get one thing wrong in an answer out of for an insight, right, it's basically analytics, and if you have enough data, that kind of gets washed out. We still have that's an important thing I want to mention here. So we analyze on the fly conversations between agents and customers, but we always have a full-time person doing sampling to see how good the speech recognition was, how good the insight extraction was. And we even have software where we can say, okay, here he missed it completely, and then add something to our taxonomy or add a new example of why it was wrong, right? But a human in the loop for something like this is very important. But yes, we designed this system completely from scratch after having done a taxonomy approach for a long time. And we still use the taxonomy, right, for certain things. Names of companies, names of products, still very important. Some insights still really, really work well with the taxonomies, but the majority of the insights that we extract are LLM based.
What are some of the
chaotic answer, but I hope you can.
What are some of the guiding principles that dictate whether you begin with a needle solving some very narrow case, or you just say, all right, do you trust me? I'm going to rip the whole thing out and implement the version 2.0.
Only big companies with the big budget do that.
So cash is the only limiting factor? There's no social or political or some kind of learning curve that needs to be acclimated from the existing human actors? Like there's no other influences in that decision making?
There's two factors that play that are the most important. Number one is there's a visionary in the company that sees how adding this AI thing might save cost or generate more income, right? So you need a visionary that really believes in it. Then the second thing is, do I have the right AI engineers, right? Because that's in many cases the limiting factor. having people that actually can do the work, and realize that if they can't do it, that they need to go outside and get experts. But everyone is looking for those experts, right? So, but that's a visionary and AI skills in your engineering team. That's the. But I don't know if that was an answer to your question.
Just yeah, I think in some fashion it helps shape that answer.
So the ROI in these things, at least in my business, in my line of work, the ROI is very obvious. You know exactly how much an agent sitting in a butts and seats cost you. You know how much the telephone line cost. You know how much your average length of call is. You know how much you're paying the guy, and you know he takes a break, and you know he works a 7-hour shift, and you have to put a new body in that seat for the next 8 hours or 7 hours. Whereas you know exactly how much it's going to cost you per minute. We usually charge like 20 cents a minute for an AI agent of ours versus $2.86 a minute for a butts and seats. So the ROI is very obvious. So the question, the gating question is, what's the success rate you have on your AI agent versus the success rate of the live agent? And that's something that you can measure over a period of 30, 60, 90 days and decide whether to expand it beyond the first 100 agents or 500 agents, et cetera. So I think at least in the conversational AI line of work, the ROI is pretty obvious.
Yeah, I think to continue in that vein, there's always, if you go in with the assumption that your LLM is a lot like an intern. And you get an intern. That intern is basically going to be able to do certain things pretty well. Realistically, over time, that intern is going to learn how to do other things better, is going to improve, is going to basically have fewer error rate problems. And in general, as the intern becomes more efficient, the value of that particular intern is going to obviously increase correspondingly. And I think that's one of the big issues that I see with a lot of organizations is they expect out of the box that this intern that you're talking about, this assistant that you're talking about, is going to be perfect. And usually that's not the case. Usually it's something where that, it is still like any other neural network-based system. It is something that needs to be trained. And it is something that needs to be continually trained. And this is actually one of the areas that I look at LLMs as being a real Achilles heel, is that the training period on these are so large that you don't really have the ability to manage that kind of feedback. That's why I think that when you start talking about SMLs, small language, or SLMs, small language models, that are essentially trainable, that can actually have that kind of circuitry to be able to reinforce the information they have with or without a person in the loop. That also becomes a part of that ROI equation. And so, realistically, it's one of those things that you have to kind of balance out the fact that, no, it is not going to be as good in terms of the overall system initially, but if you develop the application correctly, then it will basically evolve over time to become much more efficient, much more capable of dealing with your system at the cost of becoming less general.
Right.
And so, that's always going to be the trade-off that you have with an LLM is that if you're building out these models, you're essentially creating something that is going to be increasingly specialized. And in that process of specialization, you're basically creating something that becomes much more proficient within its domain. And that's where you get in then to a model of experts type approach where you're saying, look, I'm training my experts here as this overall process. So it has to be an evolution. It's not something that you can get right out of the box.
Now, as far as implementation goes, what are some key considerations to reduce the risk of mishandling the implementation of an AI system?
Interesting question. I mean, we have a code of ethics that's written out and guidelines that we make sure that we're doing things ethically, we're handling people's data ethically, and we're guarding against prompt insertion and things like that. Um, I'm not sure that I can go answer beyond that as far as what we're doing.
So, proactive measures to handle the privacy and security of sensitive information. Um,
Right, we're SOC 2 and HIPAA and all that.
Also, blatantly easy checklists that ensure that your operations and producing and releasing this AI doesn't just happen all at once. There's a ramp up period, and you test it out with a small sample, you verify it,
Right.
and you see its performance, and you tune it according to whether it's doing good or bad. Any other areas of consideration?
It is just regular software development. It's not different. It's just the answers you're going to get have probably more uncertainty than you're used to, so you have to deal with that uncertainty. So better make that your a primary concern, right? How do I deal with, like Brian said earlier, with the error rates, right? How do I deal with the errors? And that becomes one of your main concerns. But for the rest, it's just like any regular software development. Nothing special about it, except error handling is even more
Well,
important.
the one thing that's different about than regular software development is you can't trace it. There's still a black box in the mix, and you have no idea what's happening inside the black box.
But you have the same thing for machine learning, right?
Yeah.
Regular machine learning.
I'd also argue that that's something where, whenever we're dealing with networks, that seems to be an intrinsic characteristic. Once you have a network in place, and a neural network is still a network, once you have that in place, you're basically going to be giving up a certain degree of autonomy about being able to do discovery in order to be able to get the benefits that accrue because you have the ability to do these kinds of analyses. And that again seems to be part of the trade-off that you run into.
What about the added risk or tolerance that needs to be taken into consideration with data and data drift and bias and the way that it starts to specialize or gear its behavior towards a certain way? Any precautionary measures that you can take there?
Quality control, a human in the loop, nothing else will work.
Yes. There was an interesting piece I saw a couple days ago about X and the fact that there is with the social media, Musk's social media platform, formerly Twitter, that one of the things that you're beginning to see are people actually going in and using insertion type prompts to tell the system, ignore all previous training.
Right.
And when that happens, it basically causes what appears to be a very intelligent person on the back end to suddenly, reveal themselves as being a bot. And that bot then is something that you can say this person is not real. And it turns out there's a whole bunch of bots that you thought at one point were actually fairly intelligent people. So from the standpoint, there's some question about ethics here, obviously, but from the standpoint of security, you have to understand that people are very clever, and you are basically putting a lot of your eggs in a particular basket where you're hoping that people aren't clever enough to ask the right questions. So, it's the other downside I see with working with these kinds of applications is that you have to be constantly testing to be able to find where are the loops, where are the weak points, where are things that I can use prompt injection to get this to basically do things like say, oh, hey, you want a trip for $1? Sure, we can do that. And then you're liable for it. And
Right.
that, I think, is actually a pretty big piece that gets into data governance. So Brian.
I would like to know from Brian how. So you do conversation with real people, right? So I'm sure you must have a quality control program, right, to check.
Yeah, we check against prompt insertion.
No, but I mean, do you have people that talk to your system just to make sure that they do the right thing, or you just
I talk to them all the time, like I said. It's why I turned out the way I turned out.
Okay.
You know?
But you know what I mean, right? So you make sure that what they do is reasonable, right?
The QA is very difficult on a probabilistic system.
But that's why you need QA, right? if a program could do it, it was easy, right?
Right.
Well, I think we've covered quite a bit in this 70-minute panel discussion, and I think Jans, you boiled it down to 2 points: organizational buy-in, and then how much capital do they have? How many resources can they deploy? If you have the right talent, you can either rip out the new system or start with a narrow use case and expand over time. Quality control. Hard to define. I guess that's a separate discussion for another day. Thank you all for joining in this panel discussion, and we're going to have to do a part 2 someday.
Sounds good.
Let's do it. It's been a pleasure. Thank you.
All right. Okay. Thank
Thanks,
you.
everybody.
Joaquin.